So yeah, now we'll be talking about some brief introduction to your ANN again. So for those who have not been in the previous section, so with respect to that, we'll be talking to in the depth concept of your artificial neural networks. So as already discussed in the previous session about your ANN, it is a computational processing mechanism which is used for high-end computations. So an ANN is an information processing paradigm that is inspired from the working of a brain. So how a brain will be functioning so fast with respect to some neurons. So in the same manner, ANN also was developed. And ANNs, like people learn by examples. So depending upon the various examples, ANN also try to learn from the different examples, and accordingly a network structure will be obtained. Okay, so an ANN is configured for a specific application such as pattern recognition, data classification, which can be done through your learning process. So learning here is an important metric with respect to your ANN. So it will try to learn from examples from previous iterations and also for varied applications. Okay, so learning largely involves adjustments to the synaptic connections that exist between the neurons. So how a neuron will try to adjust itself whenever there is a node failure or when one neuron fails, how information will be transferred. In the same manner, here learning need to be done in the same manner how a neurons will interact among themselves. So with respect to that, the model of ANN is can be specified using three entities, that is using your interconnections, using your activation functions, and using your learning rules. So the concept whatever we are discussing about single layer feed forward and multi-layer feed forward networks comes under these type of specifications like interconnections. Okay, so however we will try to cover what are these interconnections, what is this activation functions, and what are the learning rules adopted with respect to your artificial neural networks. Okay, yeah. So as I said, the first thing is about your model of your ANN. So everybody need to keep this structure in your mind whenever you are talking about any neural network or artificial neural network concept. Okay, so in today's session, we'll be trying to learn about the important metric called as activation function, which is very important component of your ANN model. Okay, so yeah, so this structure is explaining clearly that you'll be having some input variables from x1 to xn or xm. So and accordingly, you'll be having some weights for each node. So here x1 is the input variable, and for that x1 to reach to the output through some hidden layers, it need to add some weights, right? That's how x1 input is having some weight called as w1. Likewise, each node will be having one input variable and also weight. So the working of this ANN relies in the next step, that is how an input variables and the weights will be computed using different hidden layer components. Therein, that's the reason the hidden layers are embedded with various activation functions. Okay, so here you can see the summation function here is indicating the y input. So if you want to get the input, you need to sum these all inputs. Okay, so therein that input will be transferred to an activation function f here, and that activation function will try to apply necessary computation methods or the necessary functions, and it will try to give you some y output. So in today's session, we will try to discuss about what is this activation function and what are the different activation functions available, and what is the role of activation function in a artificial neural networks. Okay, so whenever you are discussing about any artificial neural networks, the most important concept here is activation function. Okay, so everybody need to have a keen understanding of what is an activation function, which I'll be explaining in the next slides. Okay, so this structure is very useful for you in answering the examination point of view also. This structure need to be explained with respect to model of your ANN. Okay, so this is a basic model which every ANN can be a single layer or multi-layer networks can be applied. Okay, so as I said, if you want to calculate the summation function here, the sigma function, you need to do the dot product of this x1 and w1. Okay, so y in that is w into x is equal to x1 into w1, x1 w2, so on till the n number of input variables whatever you are giving. So finally, it is a summation value of wi into xi, where I equal to 1 to m. So how many input variables you are going to take, that many times dot product will be computed and it will be summed into a single place. That value will be given as an input for this activation function. You can see here y in is given as the input for this activation function. Okay, so the output can be calculated by applying the activation function over the net input, that is y equal to f of y in, that is function of y in gives the actual output value. So y is equal to y in of f, that is the output value what you're getting through your activation function. So this is a basic computation which is done in every artificial neural network. So whenever you are going to give some input variables and also some weights to that variables. Okay, so that is the basic computation of this artificial neural network model. Okay, so as I said, you will be talking about different specific specifications or the entities with respect to your ANN. So you are having three types of representations in a model, that is interconnections, activation functions, and learning rules. So first we will be trying to learn about what are these interconnections with respect to your ANN. Okay, so interconnections, as I said, comes they'll be talking about what is the type of network you are going to choose, whether it is single layer or whether it is a multi-layer perceptron. So you need to keep one thing in your mind whenever you're talking about your ANN. So it can be called as a single layer feed forward network, or also it is called as a perceptron. A perceptron is a terminology, biological terminology. It is representing a neuron. The same manner, whenever a questionnaire is asked with respect to your ANN, they can also ask with respect to a perceptron. Perceptron is nothing but here it is indicating a neural network concept here. Okay, so yeah, so interconnection can be defined as the way in which processing elements, that is neurons in ANN, are connected to each other. So how each neuron, one neuron to other neuron, and so on till many neurons are connected, that is called as an interconnection. Okay, so hence the arrangements of these processing elements or neurons and geometry of interconnections are very essential in ANN. So how this functionality is going on using a number of connections is a key thing to be understood with respect to your ANN. Okay, so the arrangements always have two layers which are common to all network architecture. So the two layers are the inputs and the output layers. So as you can see in the previous diagrammatical pictorial representation of your ANN, so here you can see, yeah, so this is what we are talking about. So any neural network or any artificial neural network has these two layers called as input layer and output layer. So if it is a single layer network, it has only input and output. And if it is a multi-layer perceptron or multi-layer feed forward network, it may have many hidden layers. Okay, yeah. So one second. Yeah, so that's how you will be having two layers in any network, and there is one layer called as third layer, that is the hidden layer, in which neurons are neither kept in the input layer nor in the output layer. They act as a mediator between the input and output, where computations are actually done using your activation functions. So these neurons are hidden from the people who are interfacing with the system, and they act as a black box to them, so that will not be visible for anybody. That's why it is called as some interconnected layer or hidden layer. Okay, so as I said, a multi-layer perceptron can have many hidden layers also. So it can be one hidden layer or it can be many hidden layers. So sometimes it may have many hidden layers also. So on increasing the hidden layers with neurons, the system is system's computational and processing power can be increased, but the training phenomena of system gets more complex at the same time, because you are having multiple hidden layers. So the computation capacity may increase, but it may consume a lot of time for training your data set, and also the expenses also may be more for doing any processing mechanism. That's the reason if you are having multiple hidden layers, that may lead you high-end cost for processing your mechanism. Okay, so with respect to the various connections of your ANN, there are 5 basic type of neuron connection architectures. So we are discussing about two among them, that is single layer feed forward network and multi-layer feed forward network, which are part of our syllabus. But these three concepts are also a part of your neuron connection architecture, that is single node with its own feedback, single layer recurrent network, multi-layer recurrent network. Okay, so this also come under your concept of your learning interconnections. Okay, so now we will be discussing about the concept of your syllabus, that is single layer feed forward network. So in this type of network, as I said, there will not be any hidden layer. You will be having an input attribute, input values, and also you'll be having an output called as y. So x1 is the input and y1 is the output. So likewise, you will be having only two layers, but input layer here doesn't have any thing to be done. So you can say you'll be having only one layer called as your output layer. So in this type of network, we have only two layers, input layer and output layer, but input layer does not count because no computation performed in this layer. So output layer is formed when different weights are applied on the input nodes. So here you can see x1 is having weight called as w11, w12 with respect to y2. Likewise, they are adding some weights with respect to every input function. So output layer is only formed whenever you are adding some weights to the input layer. Okay. So after this, the neurons collectively give the output layer, compute the output signals. So once weights are assigned, a neuron will be trained to compute the output, and such that you'll be getting an efficient output. That's the introduction to your single layer feed forward network. So while writing the questions with respect to examination point of view, you need to construct a network like this and show the representation of single layer feed forward network without any hidden layer. By mistake, if you are keeping any hidden layer, then that is considered as a multi-layer feed forward network. Okay, so as you can see here, example representation of multi-layer feed forward network. So here you are having a hidden layer between input and output layers, and you can see the weights are assigned initially at one layer, and a hidden layer will compute those weights and it will try to add next output to the output layer. That will be shown as the output to the user after doing a number of computations. So existence of one or more hidden layers enable the network to be computationally stronger feed forward network because information flows through the input function and the intermediate computations used to be defined at the output Z. Okay, so because if you are having in the, so here in this multi-layer feed forward network, you are only having one hidden layer, but in reality or in real world, you may have many many hidden layers also. But at the end, we can conclude that you'll be having only one input layer and one output layer. In between them, you can have many hidden layers. And you can note one important thing here, that there is no backtracking allowed here also. It is also unidirectional only, that is input towards output. Okay, so there are no feedback connections in which outputs of the model are fed into itself. So from Z1, you cannot come back to X1 as a loop again. It is also a feed forward network that is only unidirectional, but only difference is it will be having many hidden layers in between input and output layers. Okay, yeah. So as I said, that's the introduction to your interconnections. Now let's talk about next important metric called as your activation function, which is very useful in your ANN. Okay, so yeah, we'll be discussing about the next concept, that is your activation function. Okay, so activation function is one important computation with respect to artificial neural network. So activation function decides whether a neuron should be activated or not by calculating weighted sum and further adding bias with it. So as I said in the representation of your architecture about your model of ANN, so you can see what is the role of your activation function here. Activation function will try to get the inputs from variables x1 and weight w1, and that input will be once given to the activation function. It will try to compute the necessary action and it will try to give some output. But suppose if the output given by an activation function is not appropriate, then it can also add some bias to that. So bias here is the add-on which can be done with respect to the weights. That is, weights can be modified and thus it can reiterate the step until a desired output is obtained. That is how activation function is very useful in ANN. So the purpose of this activation function is to introduce non-linearity into the output of a neuron. So whenever you are not having a desired output, then your output can be done, or it can be a bias can be added, and again you can reiterate your process. Okay, so as in neural network, neurons, we all know that neural network has neurons that work in correspondence of weight. So weight is one important metric which a neural network considers. Next, bias, as I said. So if the weights added appropriately are not giving your decision, then you can add some bias. So bias can be the +1 value or -1 value, that is one or plus or minus 1 values, and accordingly, depending on the activation function, that thing can be managed. So in a neural network, you would update the weights and biases of the neurons on the basis of the error and the output. This process is called as back propagation. So this is very important thing, guys. Even examinations, these questions can be asked, like what is back propagation. So back propagation is one important concept which is discussed with respect to your feed backward network. So you'll be also having a back propagation algorithm, which is very important. But as per our syllabus, we are only having about feed forward networks. We are not talking about that. So whenever you are discussing about feed backward network, so back propagation algorithm is one important concept where looping is allowed, that is backtracking is allowed, and you can add your bias, you can add your update your weights, and accordingly you can give inputs to your activation function. So backpropagation is a procedure to repeatedly adjust the weights so as to minimize the difference between actual output and desired output. So assume that you have given some input variables called as x1 and weight as w1, and you want your desired output as some value as some 5.2, and assume that the desired output whatever you got is around some 4. So there is a difference of 1.2. That 1.2 can be managed using your back propagation, that is by adding weights here and there, and also adding some bias, that is removing some unwanted thing. You can get your desired output. Okay, so back propagation is one important thing which need to be understood with respect to your activation function. So activation function makes the back propagation possible since the gradients are supplied along with the error to update the weights and the biases. Okay, so that's the reason activation function uses this back propagation whenever it want to reiterate things and it want to update the weights and biases. Okay, so with respect to that, we are having different types of activation functions which are called as variants of activation function. Okay, so the first one is the linear function, so which talks about some linear data points. So linear function is similar to a straight line equation, that is y equal to mx plus c, where m is the slope. So here we are calling it as y equal to ax. So no matter how many layers we have, if all are linear in nature, the final activation function of the last layer, that is output layer, is nothing but the linear function of the input of the first layer. That is how, if you are having all the linear layers, then from input to output you'll be having a linear function used, that is as a activation function. The range of these values is minus infinity to plus infinity. So linear function activation function is used as at only one place, that is your output layer. Okay, so it can be used as output layer according to the input of the functions whatever you are having, and the range here is very important metric. So if it is asked with respect to objective questions, this type of things can be asked with respect to your multiple choice question. What is the range of a linear activation function? It is minus infinity to plus infinity. Okay, yeah. The second activation function is sigmoid function, which is very important concept in artificial neural network. So most of the concepts will be using sigmoid function as the activation function for doing many computations. So it is a function which is plotted as a S-shaped graph. So here you can see the sign graph, which is already learned in previous class, which is in the form of S shape. That's how we use your sigmoid function. And here you can see the equation to compute your sigmoid function. That is sigma of z is equal to 1 by 1 plus e power minus z. That is the formula used to compute your sigmoid function, sigmoid activation function. And by default, it is non-linear in nature. Only the linear activation function will be used to compute the linear functions, and remaining sigmoid functions are mostly non-linear. Okay, so here the x values or the z value here, you can say e power minus z. The z value lies between minus 2 to plus 2. Okay, and the sigma of z, that is y values, are very steep. So if you are changing a, because that is the exponential value here, even if there is a very small change in the z values here, then the complete value of the output will be changed. That's why the y values are very steep, which means small changes in y would lead to large changes in the actual values of the y, that is the output values. The output of a sigmoid function ranges in between 0 and 1. So previously, if it is about linear function, the values between minus infinity to plus infinity. But if it is about a sigmoid function, the value is between 0 to 1. That is, if any value is above 0.5, the output of y obtained is above 0.5, it is considered as plus 1. And if the output is between the threshold value of less than 0.5, then it is called as your 0 value. Okay, so that's what is written here. If the value is greater than your threshold value, that is 0.5, it is considered as plus 1. If the value is less than threshold value of 0.1, it is considered as 0. Okay, that's how you need to remember about your sigmoid function and the computation formulae also, and also about the range of this sigmoid function. And the next activation function is about your tan h function, that is tangent hyperbolic function. This is very important computation activation function, which is better than your sigmoid function, but sometimes this is not preferred due to very varied reasons. So this activation function that works almost better than your sigmoid function, that is your tan h function, but it is mathematically similar to your activation sigmoid activation function. Both are similar and can be derived from each other. So you can see f of x is equal to tan h of x, which is equal to 2 by 1 plus e power minus 2x. So in the previous representation, you have seen a minus z here. It can be minus x or minus z. So according to your variable indication, that can be changed. So the relationship between these two functions, that is sigmoid activation function and tangent hyperbolic function, is tan h of x is equal to 2 into sigmoid function of 2x minus 1. That's how these two are derived from each other. The range between these values is minus 1 to plus 1. Yeah. Okay. So there was a small disturbance. Yeah, I think now it's clear. So tan h function is non-linear in nature, and its range lies between minus 1 to plus 1. The linear function is basically linear in nature, and the sigmoid function and also tan h function are non-linear in nature. Okay, yeah. So the next concept is next activation function is ReLU, or we call it as rectified linear unit. So this is one more activation function, which is a by default activation function for many applications. So it is the most widely used activation function, chiefly implemented in hidden layers of neural network. So any activation function is basically used or applied with respect to hidden layers. So this is very rarely used, but by default, this is considered as a rectified linear unit function, which is used in many computations because it is very simple compared to your sigmoid and tan h function. The range lies between 0 to plus infinity values, and the equation used to compute this ReLU function is a of x is equal to max of 0 comma x. So it gives an output x if x is positive and 0 otherwise. So it will be giving only the value as positive or whether it is a 0 value. And by default, it is also a nonlinear in nature, which means we can easily backpropagate the errors and have multiple layers of neurons being activated by ReLU function. So because backtracking is allowed, whenever you are having your nonlinear type of data, if there is a need to bias, add some bias to your weights, then you can use this ReLU function or ReLU activation function. And compared to previous activation functions, this is less. It has less computation charges than your tan h and sigmoid because it involves simpler mathematical operations. Okay, so in simple words, we can say ReLU learns much faster than sigmoid and tan h functions because of the easiest computations. And the last one is about last activation function is softmax function, which is also a very important activation function. The softmax function is also a type of sigmoid function, but it is handy when we are trying to handle classification problems. So whenever you are applying your classification problems, because of the non-linearity type of data, this may not be much preferred. So usually it is used whenever we are trying to handle multiple classes. The softmax function would squeeze the outputs for each class between 0 and 1. The range is between 0 and 1, and would also divide this by the sum of the outputs. Okay, so the output of this softmax function is ideally used in the output layer of the classifier, where we are actually trying to attain the probabilities to define the class of each input. So these are the 5 activation functions which everybody of us need to keep in our mind. The first one is linear activation function. Second one is sigmoid activation function, which is a S-shaped representation, that is y is equal to 1 by 1 plus e power minus z. And the third activation function is tan h, that is tangent hyperbolic function, which is derived using your sigmoid function only. And the fourth one is ReLU, that is rectified linear unit. And the fifth one is your softmax function. You need to learn the computation of equations used, and also the range between these two functions. So how to decide a proper activation function? That is a very, very important concept with respect to ANN. So how to choose the effective or the right activation function? So the basic rule of thumb is, if you really don't know what activation function to use, then simply use ReLU, as it is a general activation function, and it is used in most cases these days. Rectified linear unit is the by default activation function which can be used by anybody, because if your output is for binary classification, then sigma function or sigmoid function is very natural for choice for output layer. So whenever you are having your linear data, then you can go for your linear activation function. Whenever you are having your binary classification or binary data, then by default you can go for your sigmoid activation function. Okay, so yeah, that's it about your single layer and multi-layer feed forward, and also about your activation function. Okay, yeah.